Welcome, everyone. Thank you for joining us at today's webinar, Conquering the Oil and Gas Production Problem, How to Rethink the Use of Digital-Led Virtual Assets, the first in a four-part series. I'm Candace Miller, Senior Director, Global Events at Birlasoft, and I'm excited to share more about our upcoming webinar series of panel discussions. Today's webinar focuses on digital transformation, but more specific to production processing and digital-led virtual assets. At a future date, Webinar 2 continues the discussion with assessing your current asset architecture, the value it can bring as it relates to your future strategy. The third webinar will look at the future architecture required to achieving a future autonomous virtual asset. The final webinar addresses the how. What is the path to get there, and a roadmap phased approach that drives real value and outcomes around your digital transformational strategy. Before we get started, I'd like to introduce you to our industry experts joining us today. Let's welcome oil and gas production advisors with Birlasoft's partner, Ren Datasim, Henry Ren and Ed Hernandez. Henry Ren has 35 years extensive experience in both upstream and downstream industry, including oil and gas production, petroleum process engineering and design, modeling and simulation, control and optimization, and more. Henry is also a principal inventor of a U.S. patent for an integrated managed pressure drilling transient hydraulic modeling simulator. Ed Hernandez has deep knowledge in various technical fields, such as process modeling, flow assurance, integrated modeling, and online real-time digital models. His broad range of experience includes implementations at Chevron Oil Company, Schlumberger, Aspen Tech, and Baker Hughes, just to name a few. Today's moderator will be Todd Wolfe, Director of Operational Technology within Birlasoft's Oil and Gas Business Unit. Todd has over 30 years of experience in the oil and gas sector from traditional IT and domain O&G. With a career focused on technology and business development, Todd is passionate about bringing unique technology and value across the energy ecosystem. During today's session, you can type in any questions you have via the question feature. All unanswered questions will be addressed in an email following this webinar. I will now hand over the spotlight to Todd to share more about today's agenda and start the discussion.
Thank you, Candace, and I really want to thank everybody who's joining us today to taking time out of their busy schedule and to participate in this series of webinars and with our partners, Ren Datasim. And with the experience that both Ed and Henry have, we're going to discuss how operations should possibly rethinking the future of autonomous virtual assets, and really how these virtual assets in the future should transform production in the oil and gas companies. And so this topic today is rethinking digital-led virtual assets is very important because as an operator has a clear vision and strategy as towards what that end game is going to be and what the challenges are going to be involved with that as you go along. So ultimately, this process and what we're looking to do is to advise you on maybe rethinking what a virtual asset would be and what the future is going to look like. So I wanted to really kick this off with first exploring a question with you, Henry. You know, you've been in the industry for quite some time, and I wanted to understand, what is your vision? You know, if we look out 10 to 15 years from now, what will a successful operations look like? And, you know, what is the, you know, those process facilities and virtual operations really going to consist of as it compares to today? So I'd like to maybe have your thoughts on that.
Thanks, Todd and Candace. Birlasoft gave us the opportunity to present our view of digital transformation for oil, gas, and the process industry. After the decade of practice, and we realize for our industry, really the software applications started from mid of the 90s with the DCS become the mature and PCN network well established. And then the client server type of software application, and then started from late of the 90s and early 2000 is kind of booming, okay, widely accepted by industry from there. And up to now, we are in the crossroad. For the digital transformation in this practice, probably really started from maybe a decade ago. And then last 3 to 5 years is become more and more accepted by the industry. And why we say the crossroad is because we, after the certain years of practice, then we realize the current infrastructure, which is IT connected PCN network, has a lot of limitations to help the digital transformation moving forward to achieve the autonomous operation, that ultimate goal. So then we realize, for the future, as a question back to the next 10 to 15 years, and I think we have a lot of work can do, okay? Well, fundamentally, we should have the 3 basic standards should established to help the operations. The one is the virtual asset framework. Doesn't matter what kind of framework, but we have to establish the virtual asset parallel framework separated with the existing PCN and can guide the operation or identify the problem. Ultimately, is support autonomous operation down the road. And the second should break the silo. Current operation, the way they set up, and historically, we developed it by this way up to today. Each silo has its own standards and own way to manage the data and manage the operation. And this is behaviors, operation behaviors or cultures were established. With the new thinking, we have to break the silo, have to let data flow, okay? And then from there, and a lot of hidden data, which is a lot of important engineering analysis impact different silo interactive data and will create it and will be displayed to the users. And the number 3 is robotics application. Robotics application currently in our industry, compared with other industry, is really behind it. And there's a history there, and I do not want to extrapolate it here, but it's not too late for us to catch up. And currently, the robotics application in our industry mainly isolated inspection area, a few of the some specific area like deboard, ROV, so on and so forth. But there's no one really think about the robotics as the part of the operation yet, okay? But down the road, the robotics will play the important role to enhance our current operation based on the PCN network, particularly for the bottom level. We talk about the level 0, level 1. Those information is difficult to gather by PCN currently, can through the robotics to extract it or create it and to the IoT network or virtual asset network and display it for the user to utilize, okay? So I think this is really the 3 major area and currently we can focus on. And for the next 10 to 15 years, once this 3 area well established, and then we are not far away from autonomous operation. That is my view. And I would like to emphasize interactive value these days is really important. And currently, most of them ignored because difficult to identify. Okay, with the virtual asset framework and all those values parameters will be identified quickly and demonstrate the value to support the operation. Okay, this is including, we talk about machine learning AI methods and the simulations, okay, all kind of simulations, and with the robotics application, virtual sensor, and ultimately you form the digital virtual asset, okay, and to achieve the goal of that for the autonomous operation, okay.
Excellent, Henry, and appreciate that insight. And one of the things that I experience in talking with customers is it seems like there's a lot of difference between the definition or their understanding of what a digital twin is and virtual sensors and IoT. So maybe Henry and Ed, can you kind of share your thoughts around your common understanding of digital twin and virtual assets, and what are some of the common misunderstandings around it?
Yes, definitely today, digital twin, digital integration is a buzzword, and everybody's talking about it. And there's a lot of confusion. And one of the confusions is, as Henry mentioned, right now we really don't have any standards. So every corporation, every company that's offering this type of technology or integration is doing it with their technology and their own understanding. So everybody's doing it a little bit differently. And what we're finding out that because of this, digital twins can become very expensive. And not only expensive, it can be very trying to bring the data from different sectors of a corporation. So if we look at digital twin, we must not confuse it with some of these 3D models that we've been showing. It's not just that. A digital twin should be a dynamic representation of the system, the physical asset, the production that it does, the process, and the whole system. As Henry said, by being able to tap into all this information and bringing it out, it will make the data much more accessible for artificial intelligence and creating those type of models and analyzing and optimizing your system. Now, for example, for the real world, we typically want to examine, what are the properties, what are the key properties in a process, the conditions that it has and its attributes. The digital twin involves not only real-time data, right, from instruments, which is going to be our static data. It's also can involve data from models. I can have models which I'm feeding it from the instruments, and that's going to be calculating further data that I need. For example, it can be calculating what we call virtual sensors. And virtual sensors are going to be data that I need, but I didn't have an instrument to give me that data, or data that can only be calculated through some type of simulation. So that's where all this richness comes from. Also, we talked about the robotics. And right now in our vertical of the kind of energy sector, we're behind other industries. And the reason we're is because, for many years, the industry was very noble and we were very profitable. But right now, I think everybody realizes that we need to work more efficient. And that's where the digital twin is going to come in and give us all this richness and data so that we can further analyze, optimize, and really have a good pulse of what's going on with our asset.
Okay, excellent. And Henry, what's your experience in, talking with folks around the, digital twins and virtual sensors and maybe their misunderstandings of what it really is?
Yeah, I remember, go back to 10 years ago, talk about a digital twin, pretty much just refer to the 3D model. Back then, the 3D model is just started to develop. And as today, and most people, most companies talk about this digital twin, they still refer to physical side of the facility. And really, the digital twin should represent the real world. The real world is very complicated, not just the physical side, and also including the products, the fluid side, and also including the both side interactive relationship and operation. Okay, so digital twin really should represent the real world. That's the my view. So I call the digital twin should call the dynamic digital twin, should including any changes. And the virtual sensor, a lot of people think about a virtual sensor. Yeah, it is a calculated sensor or one parameter, versus the physical sensor. And in my mind, the virtual sensor basically is mathematics model. It is a simulation. It is a very wide network model to represent the from the boundary to boundary facility. Okay, and any parameters not a physical sensor cannot measure and should be presented. For instance, engineering data, properties, and any the fluid properties and any attributes properties through the analysis. Okay, and this is also can be considered as part of the virtual sensor.
I'd like to add to virtual sensor is that sometimes we think of a virtual sensor as generating or calculating data that we need because we don't have an instrument to measure it there, or there is no way to put an instrument and calculate it. So we do it through a simulation. But sometimes, and let me give you an example, we do have the case where we did have a pressure gauge and it was measuring the pressure. But in a certain case, that gauge was not accurate enough to measure the pressure in the level that we needed. It was kind of slow and it didn't have the accuracy. So that's where a model would be more quick and more accurate. And in this case, we had a pipeline where the plus minus 15 pounds could make a difference in telling us which direction the gas was flowing. If we were to go just by the pressure gauges that they had, we would be having a numerous problems in operating that pipeline. So it was through a virtual sensor of calculating the pressure, even though we did have pressure measurement instruments, but they were not accurate enough to what we needed. So that's sometimes a virtual sensor is when we need more accuracy.
Yeah, I mean, sensors are very key to the future, and that technology is going to continue to evolve. And one of the things that I wanted to ask both of you and Henry, you talked a little bit about robotics and automation. That's also very key. And Henry, I think you opened up by saying the oil and gas industry's a little behind in that area. So, in the future, how should these operators be, utilizing robotics as they think about their future virtual assets?
One of the area I am thinking is, how we're going to accelerate apply the robotics for the our industry. As you said, the catch up the robotics application is the monitoring areas. Okay, so what we have currently is a lot of companies they develop the robotics, maybe through some research programs or whatever. Mainly the focus on the inspection or single function based application, and the research cycle is so long, right? And because the technical side is challenge, that's the one thing. Another thing is the funding, research funding is dying. Okay, so not many people invested. But think about the automobile industry and advanced the assembly line. They don't have the human being working there anymore. It's all robotics. So what about the process plant can achieve that kind of goal? And I think one of the area can be quickly adopt the robotics is to is focus on the monitoring. For instance, we have a lot of equipment, particularly for the remote site. and there's a lot of issues. If we have the some kind of robotics, even with a single function or multifunction, can be stored there and reduce the analysis time. That was very useful. Give it a more example is, for instance, for all the flange, leakage monitoring, and all the like vessels, okay, the vibration changes, those kind of things. And right now, people all use traditional way, use a sensor, but the sensor is not accurate and very expensive to install. If we can develop some robotics technology and can extract the monitor the status and transfer, not go through the PCM network and go through parallel digital transformation network, and then we'll quickly get the status correct and achieve the analysis. So this is also required robotics interface, data transfer interface design, but there's no one thinking about this right now. And everyone developed the robotics for the single function based application. They just do their own way. And once they deploy it and face all kind of challenge, cannot quickly deploy.
Yes, I'd just like to add to the robotics, and I know we're all hearing Henry talk about robotics, and everybody perhaps in their own mind is imagining something from a science fiction movie, because that's the way we've been influenced. But robotics can be something very simple, and as Henry said, it's for monitoring. So let me give you a very simple example of what robotics can be. And you would say, well, that doesn't sound like robotics, but it is. It could be that I have out in the field a pressure gauge, and there's no way that I can kind of get the signal from that pressure gauge so that in my control room or someplace I have a dashboard that the people can see what the pressure is. It could be as simple as having a camera pointed at that pressure gauge, and then the camera transmit the image, and then they can see what the pressure is that that gauge is marking. Or it could be the example, if I have a tank and I want to make sure there's no way I can put at that moment some instruments to measure the level, or if there's a spill, it could be as simple as having a camera out there. So again, there's a lot of applications that are really simple, and not kind of get confused with a science fiction movie about something like really, really sophisticated. It's sometimes just being resourceful.
Yeah, so it's in some cases don't overthink the automation or robotics. It could be something very simple. So I wanted to kind of talk a little bit about digital transformation and the practices involved in building a platform, if you will, that supports your digital twin and IoT future. So can you guys maybe chat a little bit about, give us your insights on what that looks like?
Well, I'm going to talk first about that in the sense that when we talk about breaking the silos, and again, as Henry said earlier, digital transformation should break the silos. What does that mean? That different sectors or disciplines should be sharing the data. They all should be aware of what's happening in the whole process. And that doesn't happen even in organizations or companies where they say they're already applying digital implementation or digital twins. We can see that the silos still exist. So I guess what I'm trying to say is I can have digital twins or digital implementation, and the silos can be still there. What does that tell us? So this tells us also that it's not only implementing technology to bring all this data together to better analyze it or to better generate more data that can be useful so that we can run more efficiently our corporation or our asset, but it's also a cultural thing. And that's, I think, one of the biggest hurdles in my career. I have quite of experience of integrating different technologies. And what I found is that it also involves a cultural change where we have to give importance to the people and their ability to share this data. Only through that can we really truly have the implementation here and get the benefit. So it also involves a cultural change.
I would like to add a few comments, and I think in order to help our audience to understand clearly, in the PCN network, usually you have the 3 or 3.5 levels. So level 0 refer to all the operations, equipment, and the level 1 refer to the instrument, and sometimes also refer to the basic PLC control. And then level 2 is referred to the SCADA or DCS system, and the level 3 is referred to the advanced package to help the DCS control SCADA, and sometimes also referred to the client server application. And level 3.5 we call the DMZ zone, and a lot of existing software applications or solutions that build on this level, and then they can interface with the level 4, which is IT or business level. So this is what the current our facility structure. So for why we say we're in the crossroad, because current digital transformation application, most solutions, they still build based on this vertical structure. And the most is in the IT, okay? And they try to gather data through from the PCN network, or sometimes back and forward. I mean, most time it's extracted, but sometimes they want to send it back to the PCN. But PCN network really is an operation network, okay? Really should be protected by, security, cybersecurity. And so does IT network, corporate IT, or even IT network has multiple layers, all right? And we call it operation IT and the corporate IT. And last 3 to 5 years, I would say most application now is shifted to the IT, but it's still vertically try to communicate with PCN. So we find that there's a lot of limitations, because one is cybersecurity requirement, and also the current software is designed based on the client server, and it's particularly legacy program, and they're very useful based on the rigorous simulation, but it's difficult to move from client server and to the new cloud edge concept type of application. So then what we're going to do? So that's the reason we refer to the rethinking is we should build a vertical, highly integrated, separate IoT network, or you can call it virtual asset network, or you can call it the IT industrial Internet of Things. And from the level 2 DCS above, because you have a data historian, is easy to integrate, okay, from parallel side. But the bottom level, equipment, instrument level, PLC level is difficult. That is the reason you need to use a virtual sensor network, virtual sensor simulation technology, and robotics. And to extract the information parallel to this vertical digital framework, which will mimic real plant, a real facility, PCN, and IT network. And I think if we establish this kind of thinking, and we can move forward more quickly, because a lot of the roadblocks that currently during the practice can be solved quickly with all the people involved. One company cannot do it. It has to be the consortium of the companies within this industry helps.
And I was going to say one thing that Ed commented on that I thought was really relevant is, culturally, an organization has to be aligned, and a lot of the senior management really don't understand, the digital transformation and digital twins. And so making sure that they're aligned with that strategy and understanding what the real end goal is really important to help driving that through the organization. So one of the other things we're talking about practices, and so what is the current practice as it compares versus the future needs, right? So how things are currently doing today versus what really is the future need. Can you guys share some thoughts on that?
I would like to lead this. Maybe Ed, you can add on. Okay.
Okay.
So the current practice, we've been practice pretty much 10 years now, and the current practice we utilize the existing simulation technology, PCN, DCS data historian, and the existing IT frame, and we bring the data to the IT level and utilize the existing model to develop the solution, try to mimic the facility operation from process scope. And then we realize there's a lot of impact from the upstream and the downstream. Then we extended it to the upstream and reached to the petroleum engineering, and they also reached to the reservoir. And we have some successful story in the past. But again, it is in the, you can call the IT level 4 type of application, but not the full. The one thing is difficult to get the PCN bottom level of the information. Okay, a lot of information is missing because, and also it's difficult to get it. Then we utilize the virtual sensor, which is a simulation model, to give us create the data we needed. And overall, this is still client-server type of application. It's 20th century technology. And two areas we are missing so far, I believe. One is machine learning, AI not applied in this application. And the IT-OT integration is not there, okay? And also the cost, mainly we have to think about the cost. The OpEx cost is pretty high. The reason is all the existing software licensing, even DCS licensing, historian licensing, whatever licensing, is really expensive. It's getting more and more expensive. For the giant oil company we served before, may affordable, but for the 90% of operators may not affordable. So this kind of application format, I believe, probably just good for the big company. But think about this: there is a maybe 90% operators. They are medium, small operators. They all have a needs to transit their current facility to virtual asset and to enhance their performance and reduce the cost. So I think if we establish the parallel vertical integrated, parallel to the existing facility, vertical integrated IIoT, virtual asset network, utilize the machine learning and AI to reduce the licensing cost, and with the robotics down the road, and to gather the more data, and us including the virtual sensor, I believe pretty much we can cover the 90% industry needs.
Yes, I agree with what Henry has said, and I like to be a man of few words, but I like to kind of summarize based on Todd's question. So one of the issues today is that there are too many players. There's too many people providing the service. Each one is doing it with their own technology and their own way of thinking to solve the problem. And one of the problems that I see today is that there are no standards. Hopefully 10, 15 years from now, we have learned enough that now we're going to have standards, and the standards are definitely going to impact the architecture, because the way Henry described the way it's being implemented and how it's tied up, that creates very awkward situations. And not only awkward, it's really painful. We had the experience that it was really painful to get in and even just look at the information. And all of that was because this awkwardness was due to IT also keeping an eye to making sure that the standards of security were obeyed and adhered to. That was another issue, security issues. So that to really a lot of awkwardness, a lot of pain. And last of all, what Henry said is it can get very expensive. So that's why I think in today's world, it's probably the medium to smaller players that maybe haven't implemented this, been the pioneers, who really have a maybe a better opportunity of taking the lessons learned from people like Henry and me and implementing in a better way that really affects how everything is interconnected and how the architecture is established.
Yeah, no, and I'll kind of wrap it up and put some closing comments here. I appreciate your insight on this, and I think it's a really important topic because, you know, this webinar series that we're putting together, the first part of it is, you know, really rethinking what the future will look like for these production process operations. And our next webinar is going to talk more about what the current architecture is and how that applies and drives the future. But it's really key, as we talked about, is that culturally we need to make sure as an organization we're aligned, that we avoid the silos. And with the ever-changing in technologies with sensors and robotics, there needs to be a real clear strategy on how this technology is going to help drive ultimately kind of what you touched on, Ed, was, you know, what's the return on investment in this, right? Because a lot of companies are talking about digital transformation, and there's a lot of money that's being put in, and they're not always seeing the results. And so I think that's where, you know, we can really bring some value to a lot of the operators out there, is by taking a step back and, you know, helping them better understand, you know, what the end game is going to look like. And so I encourage anybody out there that wants to maybe spend an extra hour or two with us individually to talk about their current operations. We're happy to, you know, grab some time with you. So I think, Candace, you're going to share my contact information. So by all means, reach out to us, and we look forward to having you continue on, everybody, in our series here. Thank you for your time.
Thank you, Todd. We really appreciate everyone attending today and hope you found this webinar valuable. A special thank you to our panelists, Henry, Ed, and Todd, for sharing your perspectives. For those with questions not covered today, we will follow up via email. Be sure to keep an eye out for an invitation to the next webinar in the series, From Strategy to Execution, Assessing and Revamping IT and OT Architecture in the Oil and Gas World. Again, thank you for attending today's event. We hope to see you at our next webinar. Have a good day.